Okay, hello, welcome to my channel. Now in this video, we want to differentiate f of x equals to sine x using the first principle. Good. Okay, the first principle makes use of this gradient function that tells us that if y is f of x, then the y dx will be the limit as h tends to 0 of this f of x plus h minus f of x, or divided by h. Great. And now I'll be using the following tool. I will use the tool is this. The limit of sine theta over theta as theta tends to 0 is just 1. So if you have sine of an angle divided by something in the denominator, and the thing in the denominator is the same thing as that angle, and the denominator tends to 0, the result of that limit is just going to be 1. Good. Okay, so let's use that and differentiate this function, f of x equals to sine x. So I put down the function f of x equals to sine x. Well, to make use of that gradient function, we will need to use f of x plus h, right? And f of x. Already, the f of x is given to be sine x. Now we need to determine what f of x plus h will be. Now look at this. Sine x, right, is we look at this. F of x is sine x, right? Now what will f of x plus h be? This is x. This is where it is appearing, all right? This is a function that when you put in anything in it will evaluate the sign of that thing, all right? So here, we will plug in x plus h. We are just going to evaluate the sign of x plus h, all right? So this is going to give us sign of x plus h. Good. That is the sign of sum of two angles, and we have a trigonometric identity for that, all right? When we have sign of sum of two angles, what do we enter with? Well, I'm just going to remind you of that. Sine of x plus h is the same thing as sine of x times the cosine of h, then plus sine of h times the cosine of x. Good. So in place of sine of x plus h, this is what we'll be entering with, all right? The whole of that. Good. Okay, so let's substitute each of those, f of x and f of x plus h, into this gradient function in their corresponding positions and evaluate the limit as h tends to 0. So what we have is that the y dx is going to be the limit, right? The limit as h tends to 0 of f of x plus h, which we've checked it out to be sine x cosine x, the whole of that. So let me just put it down. Sine x cosine of h plus sine of h, then cosine of x. Then we divide that by, okay, that is just sine, okay? We have f of x plus h to be the whole of that. Let me put it down again. Sine h cosine of x. Then we have to subtract something from that. We have to subtract f of x from that, right? Well, f of x here is just sine x, so we subtract sine x from that. Good. And then the denominator, we just enter with just h, all right? So you put down the h right there. Okay, so I'm going to do a little thing in the numerator. I'm going to do some factoring, all right? This is going to be the limit as h tends to 0 of, I'm going to pull this one down here so that we have sine x cosine h minus sine x, all right? So we're going to enter with sine of x in the bracket cosine of h minus 1 plus sine h, then cosine of x. That is so because when we push this one to this point, right, we have sine x here and sine x here. We can pull that out, right? And when we take it out, we bring a bracket. That just by factorizing. Cosine h is left here, then negative 1 will be left over there. If you multiply this again, you're going to have this term and that term. Then we're going to add this middle term to that. Good. And then we have the denominator to just be h. Okay, great. And now the next thing we'll do here is to look at what we have. All right, so we have to take the limit. Now I'm going to split these fractions into two. And as I split the fractions, I'm going to also take the limit of those sums. So we're going to have the limit as h tends to 0 of sine x times cosine of h minus 1 divided by h plus the limit as h tends to 0 of sine h over h times the cosine of x. So you observe what we've done there. I split these fractions into this one and that one, and the limit of the sum is going to become the sum of the limits of those two functions. Good. Well, I forgot to point this out to you, that when we have the limit, okay, let me just trace it out here, the limit of cosine of an angle minus 1 divided by that angle, as the angle tends to 0, the result of this limit is just going to be 0. So we have the limit as h tends to 0 of cosine h minus 1 divided by h. It has the same structure, okay? It has the same form as this, right? So the result of this limit is going to be 0, right? So I'm going to put it down here as sine x times the limit as h tends to 0 of this cosine h minus 1 over h, which has the same form as cosine theta minus 1 over theta. The result of that limit is just going to be 0. Remember, we do not take the limit of this sine x because sine x has no h in it, all right? This limit has to do with h going to 0. There is no h here, so that limit will not affect that function because it's just sine x. Good. Now we now add it with the limit as h tends to 0 of sine h over h. Again, the limit as theta tends to 0 of sine theta over theta is giving us 1. So that tells us that when the angle and the denominator are the same, and that denominator tends to 0, the result of that limit is just going to be 1. So what we have here is that the angle and the denominator are the same, and the denominator is going to 0. So the result of that limit is just going to be 1. So we multiply that with 1, or we add 1 to that, then we multiply it with cosine of x. Again, cosine x has no h with it. So as h tends to 0, cosine x will just be like a constant. Good. So we multiply this out. Sine x times 0, the result is just going to be 0. We add it with 1 times cosine x. The result is just cosine of x. So cosine x here is the derivative, okay, of that function sine x with respect to x. Okay, great. All right. Thanks for watching. Please subscribe to my channel.